So we know now in theory that the whole point of Chapter 9 is to take a sample value and estimate a population value, because usually you don't have access to the whole population, right? Seems sensible. Okay, so if that's the case, let's look at how we construct this window that we were talking about on the previous page. So what you do is you take your point estimate and you add and subtract away a margin of error. That'll create a window for you with the point estimate in the middle. You'll have an upper end and a lower end. The upper end when you add on the margin of error, and the lower end when you subtract the margin of error. So still thinking about our bean box, and again, remember that's just a metaphor. So think of our scoop as a poll of the beans. So from this poll, a statistician would say that, quote, we estimate 25% of the beans in this box are red, plus or minus 7.7 percentage points, with a 95% confidence. Now we'll figure out where they get all their numbers from later on in this section. They come from a particular place, but let's talk about the point estimate. So the point estimate that is given is p hat, which is x over n, which is 30 over 120. Now they do this all the time. If you ever watch the news or listen to a podcast, they'll say, 25% of Americans think this, or the president's approval rating is blah, right? So they'll say president approval rating is 45%. That's a point estimate that they're giving you. They're giving you the center of the interval, okay? And then in little fine print somewhere, they usually will have a plus or minus 7.7 percentage points, right? They'll put that someplace. And if you look really carefully, they'll often say what their confidence level is. So that plus or minus 7.7 percentage points, that's your margin of error. It's your give or take. It's your within. In fact, I better write those words. Look for within or give or take, that kind of thing. Right? Now I know up until this point we used give or take for the standard deviation, and that was fine for what we were doing, but now we're going to try to be a little bit more accurate, and we want to use it for the margin of error. So in particular within, I want to be within 7.7 percentage points, right? So if you see those words, those are usually talking about your error. Capital E for error. There we go. All right, so now let's compute the confidence interval from these values. Right, so what you do is you take your point estimate, which is p hat, which is 0.25, and you add and subtract away your error. So your confidence interval is p hat plus or minus your error, which is 0.25 plus or minus 0.077. Oop, 25. I lost my 5 right there. Okay, so now let me go grab a calculator. I want to take 2.25, 0.25 plus 0.077. Then I want 0.25 minus 0.077. So 17.3% to 32.7%. So 0.173, 0.327. That is your interval right there. Or you could write it with percentages. That's fine too. Just make sure you use the percent symbol. So you'd say 17.3%, 32.7%. Either one. I tend to use the decimal one more often because percentages are just glorified decimals anyway. But in the news, they'll always use the percentages because people tend to understand percentages a little bit better. All right, so now we want to draw a picture of what we just found. So I have a number line here, and I did all this in class, so bear with me here. So the numbers are percentages, so it's 15% over here and 35% over here. Then you can count away. So 15, 16, 17, you have 17.3% right here. So I have that kind of bracket there. And then I shade all the way over to 32.7. There is my window. The center of that window is my point estimate, which is that blue line in the middle. That's p hat, which is at 25%. If you count 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There it is, 25% right in the middle. That is the center of your window. Okay, and then your error is kind of the window panes in your window, if you will. So the center line, and then you add on the error here to get you 32.7, and you subtract it away over here to get 17.3%. And 7.7% is what you're adding on. So I guess I could also write it this way. 154, and then you could say 25% plus or minus 7.7%. That would also work, right? Either one. Again, I tend to use the decimals more often, but you know, it's fine. All right, that is my 95% CI. CI stands for confidence interval. Right? It's pretty common notation. All right, so we've got everything labeled. The middle of it is 90 or 0.25 and then 95%. So now what is the relationship that we see in this picture between the margin of error and the width? The width of the interval is the distance, the pink distance here, from 17.3 all the way up to 32.7. So let me write that out. So the width is equal to twice my margin of error, right? Because the margin of error, here, let me put it that way. Margin of error, computer's giving me grief here. Margin of error is equal to half the width of the interval. So for example, in our particular example, the margin of error was 7.7. So in example above, error equals 0.077. The width is twice that. So 0.077 times 2 should be 0.154. Another way to see what the width was, I should have put this in, would be that width is this pink number over here, 0.327, 0.327, take away 0.173, right? It's the high number of your window minus the low number of your window, which means that that margin of error will be half the width of that interval because it's the distance from the center out to the edge. All right, now what does that mean for the width of our intervals? If you have a larger error, that distance in here is larger, that's going to mean that your width is larger. Okay. Slash bigger, whichever word you want to use. Wider, wider width of the interval. That doesn't sound like good English, right? So larger, bigger width of your interval. The smaller your error, the smaller your width of your interval. Okay. I guess I'll go with the words larger and smaller. That makes sense. All right, let's pause right here. I know it's in the middle of an example, but this is a really long example. So let's stop right here and then we'll pick up next time with talking about the confidence level. So I'll see you back here then.